Hi, welcome to 7.3 Multivariable Linear Systems. What we're going to cover today is how to use back substitution to solve linear systems in row echelon form, to use Gaussian elimination to solve linear equations, solve non-square linear equations, and use systems of linear equations in 3 or more variables to model and solve real-life problems. The first one is an example of a system of 3 equations, and that's the way you're used to seeing it. You have 3 equations, you have 3 unknowns, everything's just put in order. You have the x, the y's, and the z's, and usually you have something in every single column. When I look at the one down here, this is the same system that somebody has rewritten in what's called row echelon form. Row echelon form means that you have like stair steps. So you have, in the very bottom line, you have one variable, and you know what that is. So I know that z is equal to 2. And then this next one equation up, I have 2 variables. And then the top equation, I have 3 variables. And what makes this easier is I'm asking which one do you think is easier to solve? Well, it should make sense to you that the second one is easier to solve because I already have one variable solved for me. So in order to solve this, I'm going to use what's called back substitution. And what that means is I take z is equal to 2, and I'm going to back that up into the equation before that and substitute that 2 in for the z. So I'm going to have y plus 3 times 2 is equal to 5, and I'm going to get y is equal to negative 1. Now, once that I know that y is equal to negative 1 and z is equal to 2, I'm going to back it up one more time and put it into the top equation and find x. So I'm going to have x minus 2 times negative 1 plus 3 times 2 is equal to 9. And when I solve that, negative 2, 6, 8, 6, 8. So x is equal to 1. So my ordered pair is going to be 1, negative 1, and 2. Going on to the next one, I have a system in linear equations. I can see that it's in row echelon form because I have those steps. So I'll pause the video now and use back substitution to find x, y, and we know z is equal to 3. Okay, I hope you had some good luck, and here's the solution that you should have. You should have your ordered pair 2, negative 3, and 3. Now, what we're going to cover now is what's called Gaussian elimination. Gaussian elimination is when we rewrite the 3 systems to make it so that it is in row echelon form. So what Gaussian elimination is going to do is teach me how to take this equation here and turn it into something that looks like that. So I'm going to go through step by step exactly how you do it. You don't have to be locked into doing the same thing every single time, but it's nice to have a pattern. The first thing I want to do is I want to rewrite my equation so that my first top variable has a 1. So I can see that the second equation and the third equation both have a lead coefficient of 1. So I may choose to rewrite one of these as my top equation. So let's say I just put this equation up here. So I'm going to write x minus 2y minus 3z is equal to 2. And then I'm going to write everything else the way it was. I'm just going to flip these 2 rows. I'm not changing anything. I have to be careful to bring the entire equation with me when I do that. Now what I'm going to do is I'm going to manipulate the rows so that the x's from these 2 equations go away. So it's very similar to elimination when we were doing a 2x2 linear system. So I'm going to call this row 1, row 2, and row 3 so you can follow along at what I'm doing. The first thing I'm going to do to eliminate this x here is I'm going to take 2 times row 1. Maybe I'll make it negative 2. That way it's just opposite and I can add. So if I multiply row 1 by negative 2, I'm going to have negative 2x plus 4y plus 6z is equal to negative 4. I'm going to leave row 2 exactly the same. So I'm going to have 2x plus 4y plus z is equal to 1. And I'm going to add those 2 rows together. When I add those 2 rows together, this will be 0, which is what I wanted. I don't need to write it, but I'm writing it to show you. Plus 8y plus 7z is equal to negative 3. at this point, I want to start getting organized, so I'm going to organize myself here. I like to put this little box up here off to the side of my paper. And the first thing I'm going to do is write my first equation. And then since I have an equation with two variables, so I'm trying to make those stair steps, 8y plus 7z is equal to -3. So now I'm trying to make the stairs, you know, so that it's in row echelon form. So I used row 2, I used row 1, and I used row 2. I now want to combine two other rows so that I can eliminate the x. I'm probably going to go back to row 1 and row 3. I can use row 1 and row 3, or I could use row 2 and row 3. It does not matter, as I just cannot use the combination 1 and 2 again. So let's say I use row 1. So let's leave row 1 exactly the way it was. So x minus 2y minus 3z is equal to 2. And let's multiply row 3 by a negative sign. So that'll be negative x minus y plus z is equal to 1. When I add those, I'm going to have 0 here. Negative 3y minus 2z is equal to 3. Now, I don't need to put that in my box up here because I already have an equation with two variables, so I don't need to do that. But what I do notice is at this point here, I have this equation with a y and a z, and I have this equation with a y and a z. So I have two equations with two unknowns. I can put those together and solve them. So I'm going to write those down next to each other so it's easier for me to see. So I'm going to extend the page here, and I'm going to write 8y plus 7z is equal to -3. I'm going to write negative 3y minus 2z is equal to 3. Now, I'm probably going to decide, I have to eliminate either the y or the z. Doesn't really matter which one. It's not pretty, so I'm just going to go ahead and eliminate the y. So let's say I multiply this top equation by 3, and I'm going to multiply this lower equation, I'll switch colors for you, by 8. So when I multiply the top equation by 3, I'm going to have 24y plus 21z is equal to -9. When I multiply the lower equation by 8, I'm going to have negative 24y minus 16z is equal to 24. These will drop out, and that's what I wanted. I wanted 0 here, so we'll have 5z is equal to 15, which means z is equal to 3. I'm going to go back here to my box, and I'm so glad that I organized myself so I didn't lose anything. I'm going to say z is equal to 3. Now I have that stair step that I wanted, so now what I'm going to do is I'm going to use back substitution. I'm going to take this 3 and put it here. So I'm going to have 8y plus 7 times 3 is equal to -3 and -3. So I'm going to have 8y, that'll be 21. So is equal to -24, y is equal to -3. Take the y and the z and substitute it back into the original first top one. So I'm substitute back into here. And I'm going to have x minus 2 times -3 minus 3 times 3 is equal to 2. So this would be plus 6 minus 9 is equal to 2. Minus 3, so x is equal to 5. I hope I'm doing my math right. There's no one here to correct me. So my ordered pairs are going to be 5, -3, and 3. And that's just an easier way to solve a 3 by 3. So here I have this one. I'm going to give you a minute to pause the video, try and solve it. Remember, you may not be doing the same work as your neighbor. As long as you're getting the same answers, you're good. So I'll give you a minute, pause the video. Okay, these should be your answers, 1, 2, and 3. All right. I'm not going to do that one. All right, so now let's talk about non-square system. We talked a little bit about square systems and non-square systems before. We said when you have a square system, you have 3 unknowns and 3 equations. In this case, I have 3 unknowns and only 2 equations, which means I cannot solve the system. I cannot find out what x is equal to, what y is equal to, or z is equal to. But what I can do is I can find out how the variables relate to each other. So that's something that I can do. So we're going to first start by trying to eliminate one of the variables. So the easiest variable for me to eliminate at this point is z. So I'm going to add those first and second equations to eliminate z. So when I add those 2 equations, I'm going to add, and I'm going to have 3x minus 3y. The z's will drop out is equal to 3. At this point, I see that everything, I have 3, 3, and 3, so I'm going to divide everything by 3. You have x minus y is equal to 1. So I'm going to say x is equal to y plus 1. So what I decided to do is and when I read it like this, and you could have done it the other way, you could have said y is equal to x minus 1. Doesn't really matter. When I did it this way, I'm saying for x, so when I think of my ordered pair, for x, I'm going to write y plus 1. For y, I'm just going to write y. And now I have to see what z is equal to. So once I know that x is equal to y plus 1, I'm going to put it back, let's say I put it back into the original one. So what I'm trying to do is I'm going to try and write z in terms of y. So all my variables would be related to y. Again, you can do this where you relate all your variables to x. It doesn't matter. And I'll show you what that looks like when we finish. So here, when I substitute this back in, I'm going to have y plus 1, that's my x, minus 2y plus z is equal to 2. Combining like terms, I'm going to have the opposite of y plus 1 plus z is equal to 2. So solving z, I'm going to have z is equal to y minus 1. Now y plus 1. Y plus 1. Oops, my bad. Y plus 1. So what that means is if I said that y was 3, then x would have to be 4 and z would have to be 4. This is just telling you how one variable relates to the other. So if I put in 4, 3, 4, it should solve the system. Here's another one that you can practice. And I want you to compare your answers with each other because you're not going to have the same answers as me, or you may have different answers. Just make sure that if you substitute in a number, you get the same relationship between those numbers. Okay, here's your homework, page 527, 3, 8, 13, 18, 19, 27, 31, 53, and 60. If you did not do from the other page, page 503, 66, and 68, you need to do that tonight as well. All right, hope you have a great weekend, and I will see you on Wednesday. Thanks. Bye.